So in this video is the solution for the Preboard 2 4A quiz number 1 fluid mechanics. Now for number 1, we have here a 30 centimeter pipe which delivers a 2 cubic meters of water per minute through a Venturi meter shown. Area 2 is 1/10 of area 1. If the pressure head in area 1 is 6 meters, compute the pressure head in area 2. So here in this figure, we have here the area 1 here at this portion, and we have the area 2 at this portion. The diameter for area 1 portion is 30 centimeters. Okay, so this is 30 centimeter diameter. Now, how do we solve for the pressure head in area 2? So for the pressure head, we will use the Bernoulli's energy equation. So we have here energy at at 1 is equal to E sub 2. So for E sub 1, we have our datum line here. So this becomes our datum line. There you go. So this serves as our datum line. So if that is our datum line, so we have here the elevation head plus the velocity head plus the pressure head. So pressure head, that is equal to the elevation head plus the velocity head, then the pressure head. So from the figure, we can see here that the pressure head in A is 6 meters. So here we have the elevation head as 0 plus we have here the velocity head plus the pressure head at 0.1, and that is 6 meters. That is equal to the elevation head at 0.2 as 0 plus the velocity head at 0.2 plus the pressure head at 0.2. So how do we solve for the velocity on each point? So we need to get the area. So we have the formula Q is equal to area times the velocity. So need to compute for the value of Q. So Q here is equal to volume times time. So our volume here is 2 cubic meter of water per minute. So we have here 2 cubic meter of water per minute. So 1 minute. Then we will convert that into meter per second, so that per minute there becomes 60 seconds. Therefore, we have Q now equal to 2 divided by 60, and that is 0.033. So 0.033 cubic meter per second. So now we have the value for Q here. How about the area? So we have different areas. So we have area 1 is equal to pi over 4. The diameter here is 30. Or that is 0.3 squared. So that is shift pi over 4 times 0.3 squared. So 0.07 square meter. For area 2, it says here, area 2 is 1/10 of area 1. So, area 2, therefore, area 2 here is equal to 1/10 of area 1. So, that is 0.07. And that is equal to, so 0.07 divided by 10. That is 7 times 10. Or, yeah, that is 7 times 10 raised to negative 3 cubic square meter. So we now have the area. Now for the velocity now, we have here 0.0333 equals 0.07 times V1. So V1 is equal to 0.0333 divided by 0.07. That is equal to 0.476. So 0.476 meter per second. Now for velocity 2, that is 0.033 or 333. That is equal to area of 7 times 10 raised to negative 3. Velocity 2. So velocity 2 now is equal to 0.0333 over 7 times 10 raised to negative 3. So 4.76. So they're the same. No, they're not the same. Sorry. 4.76 meter per second. Then substitute it in this equation here. So we have 0 plus V1 0.476 divided by 2 times this acceleration of gravity plus 6 equals 0. Velocity 2 is this is in squared. Okay, so 4.76 is squared all over twice of the acceleration of gravity plus the pressure head at 0.2. Therefore, we now have 0.2 over gamma, or that is the pressure head, is now equal to 0.476 squared over 2 times 9.81 plus 6 minus 4.76 squared all over 2 times 9.81. So that is 4.86. So 4.86 meters. Okay. So from the choices, which one is the nearest from this answer? That is letter B. Okay. So the answer here is letter B. So that's for number 1. Let's go to number 2. A timber member, 3.65 meter long, with a cross-sectional area of 580.8 square centimeter, will be used as a buoy in salt water. What volume of concrete must be fastened to one end so that 60.96 centimeter of the member will be above the surface? So, So we have here timber with the cross-sectional area. So given the cross-sectional area, and then we have here buoy. So it's not mentioned what is the shape of the base of the buoy, and also there's no mention of the shape of the concrete. So the concrete is fastened to one end of the buoy. So you can imagine here that the buoy would look like this. So this is our timber, and then there's a concrete fastened at the end. That's why it's going to project upward. And this is our salt water. And the timber is 3.65 meter long. So that is 3.65 meter or meters. And then the area here, the area is equal to 580.8 square centimeter, and we can convert that into square meters. So that is 1 meter over 100 centimeters squared. That is equal to 0.058 square meter. Then it says here what volume of concrete must be fastened to one end so that there is a 60.96 centimeter of the member above the surface. So we have 60.96. So that is 60.96 centimeter divided by 100, and that is 0.6096 meter. And if we get here 3.65 minus 0.6096, we have 3.0404 meter. Okay, given the specific weight of timber, so the specific weight of timber is, so gamma timber is 5.9, let's just say 5.969 kilonewton per cubic meter. Gamma of salt water, that is 10.053 kilonewton per cubic meter. And then we have gamma of concrete as 22.777 kilonewton per cubic meter. Okay. So here we are solving a buoyancy problem. So if we are solving for buoyancy problem, so we have here the weight of the timber. Let's say that is weight number 1, and then weight of, okay, let's say that is weight of timber, and then this is weight of concrete, and then we have the buoyant force. So buoyant force here, buoyant force for timber, and then we have the buoyant force for the concrete. Okay, so if we get the summation of forces, we have here weight 1 or weight timber plus weight of concrete is equal to buoyant force for timber plus buoyant force for concrete. Now for the weight of timber, so we have here weight of timber is equal to 5.969 times the remember that for weight we're talking about gamma volume. Okay, so here in this bracket will become the volume. So volume of timber is the base, so the base 0.58 times the height 3.65. That is equal to 1.26 kilonewton. So we have weight of concrete is equal to gamma volume. So gamma for concrete is 22.777, and then the volume of concrete. Then we have the buoyant force for timber, and that is the salt water. We're going to use the liquid where the timber is submerged. So the submerged portion for the timber is gamma of salt water multiplied with the volume submerged. So the volume submerged here is base 0.058 times the height submerged. So that is 3.0404. That is equal to 1.77 kilonewton. Now for buoyant force for concrete, we have here the gamma for concrete. The solid is submerged in this liquid. So we're going to use the gamma of the liquid where it is submerged. So this is 10.053 gamma of salt water times the volume of concrete. So that's the volume of concrete. And then we substitute all of them to this equation number 1. So we have here weight of timber as 1.26 plus weight of concrete 22.777 volume of concrete. That is equal to buoyant force for timber 1.77 kilonewton, or let's just say 1.77, plus buoyant force for concrete is 10.053 pc. So volume of concrete now is equal to 0.04 cubic meter. So from the choices, then the answer here is letter B. Okay, so the answer is letter B. So that's for number 2. Let's go to problem 3 to 4. So here is the situation, and the question here is for number 3 and 4. The situation here is that the cylinder in the figure rests on an inclined plane and is immersed in liquid up to its top as shown. Unit weight of water is 9.79 kilonewton per cubic meter. Okay. So what is the question here? For number 3, determine the horizontal component of the force per unit weight exerted by the water on the horizontal cylinder. So it's looking for the horizontal component, and that horizontal component is F of H. So this is F of H. For number 4, we need to determine the vertical component of the force per unit weight exerted by the water on the horizontal cylinder. So we're looking for the F of V. So somewhere here. So F of V. So how do we solve for the F of H first? So as for the F of H, you need to see what is the total horizontal part that is being seen by this side at the side view. Okay, so if this is your eyesight, so side view, so what can you see? So you will be seeing here this plane. So if this is your eyesight here, what you can see, if this is a cylinder, that is resting. So the cylinder is like that. But we will consider the width of the cylinder as 1 meter. Okay? So what is being seen by this eye? It can see here this. A rectangular shape with dimension 2 and 2. So that is total of 4 meters. Now, we should not forget that there is a small portion here, since the point of contact of the cylinder is on an inclined plane. So we can see here that, okay, or let's just erase it. So we can see that there is a portion here that is to be considered as well, to be deducted. Why deducted? Because the force here is horizontal going to the right, and the force here is going to the left. So there is an equal force at this portion. So what will happen, since there is an equal force on this lower part here, we can already remove it from the horizontal force. Since they have similar force here, so the force exerted by the water on the horizontal cylinder is actually the portion here. So it's just this portion. So if we draw the rectangular plane, okay, so what the eyes can see here, what it is seeing is that this portion. So what is the dimension of this portion now? So let's say this is the 2 meter radius. Let's name this as Y. This portion here, Y. So what is the total? What's the total H here? So we can get the value here. This is the line perpendicular to the inclined. So what is the angle formed here? The angle formed here is what? So let's close up it. So this is 30 degrees inclination. Therefore, if we draw here another line, so this is 30 degrees. This is the line here is perpendicular with the incline. Therefore, the total here is 90 degrees. Therefore, the angle here is 90 minus 30. Therefore, it becomes 60. If that is 60 there, therefore, the angle here becomes 30. Okay? So, that's the explanation there. That's why here it's 30. In short, if we're dealing with incline, okay, so the angle of inclination here is the same with the angle here. That is 30 degrees. So how do we compute for your value of y? Okay, and we need also to get the value of this one here. So we know that, okay, so we extend here the level of water, and then we extend here the point of inclination here. We need to find the value of x. What's the value of x here? So for value of y, we have here cosine 30 equals y over 2. Therefore, we have y is equal to 1.732 meter. And then, we have the value of x. We have sine 30 equals x over 2. Therefore, x is equal to 1 meter. So, for number 1, or for number 3, we're looking for f of h, and that is gamma bar HA. So what is the bar h here? The bar h is at the centroid of the plane. So what is bar h here? Center of the plane. So we have gamma of water 9.79. Bar h is 1.732 divided by 2 multiplied with the area, which is the area of the total area here is the total height, I should say. The total height here is 2 plus 1.732. This is actually the h times the width. So we're dealing with per meter width. So f of h now is 68.17 kilonewton. So from the choices, we have here the nearest as letter B. Next, we have number 4. Determine the vertical component of the force per unit width. So what volume are we going to consider here? We are going to consider this volume. That volume. Okay? So we need to get this area. So we need to get this area. And sorry, it should be this one. So we need to get this area here and the area of this one here, and it's called a sector. So how do you get now this area? So the angle here is 180 plus 30, so that is 210 degrees. Okay, and then we need to compute for the area of the trapezoid. So for the area of the sector, okay, since why are we getting the area? Because of the formula for FV equals gamma volume. So we need the area. So area of the sector is equal to 1/2 radius squared theta. And then we need to convert that. So we need to convert radian. So pi over 1/8. That is equal to 1/2. The radius is 2 meters squared. The angle is 210 degrees. And then we have pi over 1/8. So area of the sector now is 7.33 meters squared. How about the area of the trapezoid? The area of the trapezoid here is 1/2. And then we will consider here the base as this one here. So this is the base 1, and then this is the base 2. So the base 1 here is 3.732 plus 2. Then per meter width. So no, not yet. Okay. So it's the height. It's not the per meter width, it's the height. Okay, so here the x is the height, which is 1 meter. So we now have area of the trapezoid as 2.866 meters squared. Therefore, we now have FB equals gamma of the water 9.7979, multiplied with 7.33 area 1 plus the area 2, 2.866 multiplied with 1 per meter width. So that's the per meter width. That is equal to 99.82 kilonewton. So from the choices, we have here 99.82 letter D. So that's for number 3 and 4.